Kaspa for Powershell allows you to make calls to Kaspa REST API endpoints, and here is REST API endpoints. Most of the commands available in this module maps directly to those endpoints. There are some exceptions, like for example those last 3 commands here, but the rest of them maps directly. Now we're gonna briefly look here at all those commands, see how their parameters correspond to REST API requests and query parameters, so that we could provide information that would allow us to extract information from the blockchain. First, we're gonna look through network info. Now, most of those endpoints here doesn't require any input. The only one that requires it, I think, is this one. It requires also switch in billion, which will display information as rounded to billions. Rest of them doesn't require anything. So let's try to execute some of them. Now we got get virtual selector parent blue score. We got this command here. The command, most of the time they will have similar name, so it will be easy to understand which one you want to get, which endpoint you want to get. And let's execute this. So we get this information. If you want information about what are blue scores, then refer to Kaspa documentation. Next one is get block doc. So here's next one. Next one is coin supply. So get coin supply. And we get information there. So remember that those values here are in most of the time are in SOMPy. This is not Kaspa directly, this is a SOMPy. And if you want to know how much Kaspa it is, then you would have to divide by SOMPy. And if you don't know how much SOMPy is 1 Kaspa, you can use this command, get SOMPy per Kaspa. This is the amount. So for example, if you want to get max supply in Kaspa, then you can do this. Get max supply, and this is the number you're gonna get. As you can see, it's shorter. This is the supply, because here is some really strange, very big number. Okay, so let's move on. We finish it with get coin supply, I think. Yes. Now let's get circulating coins, and this is the one with the switch. Remember, let's for example execute without switch. This is what we're gonna get, and if we add the switch billion, you get this. If you are not familiar with Powershell too much, if you're wondering, those are switches like this. And there are different switches here. Some of them are default switches that Powershell provides, but we are interested here at this point in only in the ones that we need to pass that represent the input information to those endpoints, which in case of this command is in billion. And as you can see, it's similar the name. It's a little different here, but it's similar enough so that you could, looking at the API, figure out which parameter you need to pass. Okay, so let's move on. Get total coins. Get Kaspa info. Get network. Now get network and get block doc gives you the same output. Currently, one of them will be probably gone in next API update, but at this point they exist, so they are present in the Kaspa for Powershell model too. Okay, so the next, get fee estimate. And as you can see, you get some data here. However, you cannot see it all, and it looks strange. So first, we're gonna do format this data as a list, so it would see this better. Okay, so we know that we have three properties here. To add this property on a command, you can do this in two ways. One is wrap this command in a brackets, dot, and then add this property, which means normal buckets like this, and you're gonna get data that is stored in this. As you can see, you cannot see this data here because the only thing you see is that there is some data here, but you don't know what type of data. So you need to access those properties sometimes, like this. Or you can do it this way: store this information in variable and R, and do this. Okay, let's move on. Get price. This is current price to the Kaspa. Get border cravart. Get halving. Remember that if you want, you can always format to have them like this. Display it. Get hash rate. Next command. Get max hash rate. Once again, you cannot see whole information because this you see that there is some object here, but you don't know what type of job. That's a block header, but you cannot see whole data. So if you would like to access it, then you can wrap this like this, and then get block header, and then you're gonna get information what's stored there. Next is get half state, and let's format this as a list so it will be easier visible. Okay, so we get this information. We can see that there is some database, but it's some objects, we don't know what. So let's look at this, like, so you access it, and this is it. And the last one is get market cap command. Okay, let's start now with another section. This time I'm gonna brief overview of blocks endpoints. We have three similar sounding commands: get block, get blocks, and get blocks from BoostCore. Here, get block requires block ID. This is required, and two additional switches or this include transactions, include color. Get blocks is similar but requires low hash. This is, I think, this is the hash we're gonna pass, and it will get, as you can see, it will list blocks beginning from a low hash, which means this is a starting hash, and it will list all the blocks that are starting from this hash, which is after this hash happened. And I think they have to be part of the blockchain. I'm not sure if the theoretical returns that are not the ones that are not part, to be fair. Okay, but let's move on. And blocks from BoostCore will list blocks of a given BoostCore. So let's execute this one. We get block. And let's this is our block. So we get some information. Let's format this as a list. so it will be visible. Okay, so we get header, transactions, verbose data, and extra. And if you look at the response, this is what you are getting. There's a header, there's the transactions, there's verbose data, and there's extra. And you get some, sometimes you're gonna get more information or less. So let's access this data. You can access this data in two ways. First, you can wrap this command in brackets, and then you can access this data by dot header. You get access to this data, and if you would like to get access to parents, they're gonna get similar, but you don't have to anymore wrap this. You have a header, you can continue and get parents. And since this is a list, probably, because this is, as you can see, wrapped, you can probably execute count 44 parents. And you can access each parent separately by specifying like this. And remember, this is some information additional, so as you can see, you are getting once again, so you can format list, because if you actually sit here, there is a, where it is, we are accessing header, which means we are header, and parents contain some information like this. So it's contains a list of parent hashes. So once again, parent hashes, this is it. So you would have to probably and get this to get this information in a raw format. Once again, this is more of them. There is a count, so there's a 2, so you can access first one and the second one, etc., etc. Okay, so let's move on. Now get blocks. Get blocks is similar. Just that we're gonna once again this. And it will list block beginning from a low hash. Okay. So once again, let's format this information. Okay, so get block hashes. Do we have any additional? Oh, includes blocks. As you can see, this is, we are not seeing, there are blocks, but we are not thinking, we get hashes of those blocks. However, we don't have those blocks itself because we didn't include that blocks. So let's do something different. Let's do this and include blocks. Once again, format list. It will take a little more, and as you can see, you get now information. You get blocks there. Okay, so now let's store this information variable. And now let's once again format list. Let's see what's there. Blocks. So okay, so we want to add such blocks. No, there is a lot of blocks, and as you can see, once again, you are getting some objects here. So how many of them there are? Count. Oh, 251 blocks. So let's get block number 1. Once again, we get some data. Let's format it. Okay, we get header, transactions, verbose data extra. We didn't include the transactions, remember, from switch here. Oh, it's a long way here, but we didn't include the transactions. So there are no transactions here. But we get header, we get verbose data. So let's look at verbose data. And again, you get transaction IDs. However, you don't have full transactions. And you can continue for example, verbose data, what transaction IDs, and because this is you can already see that there is a list because this is IDs. So let's see how many of them there are. 10 transaction IDs. Once again, you can print them all, or access one by one. Okay, let's move on. Get blocks from blue score. Okay, we're gonna need to get some blue score here. This is blue score, and the only additional parameter we can pass is include transactions. This time we actually include those transactions. We get this. Once again, let's format this as a list. Okay, so it seems that we have some blocks. Let's store this information in variable. It seems that we have 2 blocks, but let's confirm this. Dot count. Yes, there are 2 blocks. As you can see, they are split here. Okay, so what we can do? We can access block number 0, format as list, and once again you get the same information what in previous commands, because this is a block, and block data looks exactly the same in all of them. So once again, you got header, transaction, first block data extra, and so on. You can access this by doing, header, and so on and so on and so on. The same here. You can timestamp. You can access. You can get value here. Okay, so the next section we're gonna look at are transactions. Now there are 4 endpoints. However, we're gonna skip one, the submit a new transaction. We're gonna look only on those 3. We cannot skip submit new transaction because it requires also additional information like script publicly and so on, and we probably need to generate it from a wallet like API, and we don't have it. But we're gonna look at those 3 here. Get transaction, serve transaction, and calculate transaction mass. Okay, so get transaction, let's see what's there. Okay, so we need to provide transaction ID. Additionally, we can provide the block hash that contains those transactions. This is additional. We can include inputs, outputs, and resolve outputs, private points. Okay, so get transaction. Let's grab some transaction. This is a block. Well, here we got some transaction. Yeah, let's grab this one. So we got some information. Okay, we got transaction ID, we got hash, we got some block time. You can check video about timestamps, because this is a timestamp, and if you want a readable format like here, you have to use one of those 2 commands to convert it. There is a video about using them, so check it. Okay, so as you can see, we don't have input and outputs because we didn't specify that we want them. Include inputs and include outputs, and now we get basically this. And let's see, those are this is our inputs, and those are outputs. So let's access those information in different way. Let's do this. Inputs, and let's see, only one input, and you have this input, and if you actually go to this input, then you're gonna see there's an index. I think it doesn't show here. Does it show it here? No, it doesn't. Let's see. maybe it will show. Oh, okay. But transaction count, does it contains this information? No, it doesn't. I think it contains let's see what's this what information we're gonna get. Inputs, transaction ID, previous. Oh, we need to resolve, I think, output. Okay, we need to add one more switch there. So let's resolve previous outpoints. Oh, right, because this value can have one of those three settings. So let's do full, and now we have amount, just like here. Previous point amount here. We got here this, and probably we need to, if you want to get this amount here from previous output, then you can inputs and then previous output resolve it, and amount. Okay, let's move on. Search for transactions, what's doing by this. So we can pass probably more IDs. Yes, we can pass multiple IDs. So for this command, we actually pass it only one ID, transaction ID, but here we can pass multiple of them, or we can use blue scores. So search for transactions. As you can see, those are blue scores. I'm not sure. Let's see. Do we get? Yes, we're gonna get some from those blue scores example. But let's use instead of blue scores, let's specify transaction IDs, and yeah, let's use those transaction IDs. Store this. Information in variable, and let's see how many of them there are. 2. You know what? Let's grab the ID of one of them, and let's see it here. Okay. Oh, actually, let's see it in Kaspa Explorer. It will be better because we got timestamp here. We got the timestamp. It's accepted. It's accepted. And so on and so on. There are outputs, as you can see, and there are outputs, inputs and outputs. I think this information, outputs and inputs, is better visible on the Kaspa for you. So there is a one sender, one recipient, which is one input, one output. And if you actually check this and the inputs count, there's which one? Oh yeah, because we had 2 transactions. We needed access to the one here, which means the second transaction. And there's one input and one count, and one, just like that. You can access the output. Let's see. We got Kaspa address here, PPR9, and the end is 7x. Yes, this is the same. Okay, so let's move on to the next one. This was the search for transactions. We're gonna calculate transaction mass. So we're gonna need request. Request requires a transaction. However, not all of the transactions are supported, and the ones I think I found they are supported are the in the format that you get from a block. Because if you get transaction from this, you're gonna get some information like version. Let's see. It doesn't contain all the information that you need for to fill this data. So we need to grab the transaction, but grab it from a block. So can we get the block from transactions? I think, yeah, accepting blocks crash. So probably we could get transaction, get this block, and get the transaction from this block. But we're gonna do it simpler. We're just gonna get some block, random block, which means that we're gonna get some blocks, include transactions. Okay, and we're gonna dot. Let's see first. Let's be what we get. Format this as a list. Okay, so we get blocks. So we need to access at least one block. So let's grab one block. We get transactions. Let's continue. And one transaction, let's grab. Let's store this in variable. Okay, and now calculate transaction. And this was, remember, and this was okay, this was yeah, this was coming from a what command? Get blocks, because there are different inputs at this point. I may to unify this, but at this point I keep them separate, and we can calculate. Oh, this one didn't. So let's grab maybe it will. This is calculable. Not all of them can be calculated. Some of them come from minor. Some of the transactions from minors, so you get zeros, zeros, zeros. Some of them can be calculated. It depends. Once again, you would have to refer to Kaspa documentation to understand this more. Okay, so I think that's the end of the section. As I mentioned, that for this we don't have all information that we need to actually submit new transaction. We would need access to some wallet API probably. Okay, so the last section of the REST API we're gonna look for at is addresses. So we're gonna get balance from Kaspa address. Let's see. The only thing it requires is basically a Kaspa address. So let's grab some address. Where is Kaspa for you? We're gonna get to top 100. Yeah, grab this, and we have this. If you are seeing difference, well, because this is probably wrong number. So let's see. Let's grab the number here. And let's divide it by get some P for Kaspa. Let's see, maybe why? Oh yeah, because I want balance here, and we got well, there is a small difference. Maybe the site doesn't update it, data at this point. We are getting directly from blockchain, so we may have better information. Okay, so the next one is what? Get UTXOs, open UTXOs for address. So once again, we're gonna grab the same address we used before and get open. I think I don't remember. So let's see what the commands are. Get UTXOs for address. Okay, get UTXOs for address. And let's pass this address. Once again, format list. So we get like this something. we can see that there are three of them. You have to count them. Okay, so we get address, we get old point, we get UTX entry, which means there is more information. And the format, as you can see, this is UTX entry is basically a format like what it is. Old point have format like this, and UTX entry format like this. So there is definitely a lot more information. Let's store this information. And let's access what we want to access. Old point. And there is a transaction IDs. Yes, and index. Yeah. So let's access UTX entry. Once again, format as list, so we could basically better view have of this. And as you can see, there is some information. Script public key. Once again, you can access for each of those, or we can basically simple T for one, and etc. Okay, get UTX source for addresses. Now we can pass list of the addresses. So it's the same. Let's see. Get UTX source for addresses. And let's grab some addresses. What is? Let's use this one. And let's use this one. And get whole list of that. So once again, let's store this information in variable, because we cannot manage this if it's long. Okay, so let's see how many UTXs. 189, and you can grab first one, for example, and the format of UTXO is probably the same like in the previous command, which means like in get UTXOs. So you get address, old point, UTXO entry. So once again, you access this information in the same way. There's the old point format and so on and so on. So next one is get full transaction for address. This is using offset. So for example, offsets works like this. If you have, for example, you set limit 500, if you have 2000 transactions on an address, and you starting offset is 0, and you get, for example, 500 transactions set maximum to, then you could get transaction from 0 to 499. Now, if you set offset to 500, then you're gonna transactions from 500 to 1000, and so on and so on. But we're gonna skip this. Because we get similar. Oh no, actually, let's use. Let's commands, and this is get full transactions for address. Get full transactions for address. What requires? There's a Kaspa address. Okay, let's grab some address. Just remember that those transactions get all the transactions. So if there is a lot of transactions, you may wait a long time. This one, actually, we're gonna use offset 0. So we're gonna 500, which should be quite fast, I think, even on some big address. But we're not gonna risk. We're actually gonna pick some small address. Let's hope that's small. Things like this you probably would cache, so that they would faster, because there's a lot of transactions, and if you're gonna be constantly downloading them, it would take a lot of time. So we're gonna get this. What's there? We're gonna limit is 500 transactions and offset. Yeah, we're gonna start from 0, and that's and let's store this information in variable once again. Let's see. Were there at all 500 transactions on this address? Well, there are only 23 transactions. Which one it was? It was this one, I think. Yeah, 23 transactions. Okay, so we did not. So we can do something different, I think. We can limit of 10 transactions. Let's start 0. Count, we got 10 transactions. But let's start this time on offset 10. And let's see, remember the last one transaction here, ID. And we got different we started from 0, 10 transactions. Now let's change this. Let's offset from 9. We should then I think see the first transaction here will be, remember I told you to remember it, this one here. Okay, so let's move on. Next one will be get address active. Well, this symbol checks if address has had any transaction in the past. Okay, get no. Well, you know, because I don't remember commands. Let's see, get address active. Where it is, get addresses active. Do we have it? Get addresses. Oh yeah, so this is exactly this one command. So get addresses active, addresses. No, this is, yeah, this one. A list of addresses. So let's check those addresses. Which ones? Let's grab, for example, this address, and let's grab this address. Let's perform were they active. Oh, it's taking a moment. Let's look at the command. Okay, we got the information. Yes, they were. Okay. Okay, so another one is get full transactions for others page. This one you can specify the timestamp after which you want to transactions or before which one you want transactions. And this is the concept of timestamps where it comes. And if you actually there's a video about timestamps I made, and those two commands come handy for this. Because once again you have to provide the timestamp as a datetime as a timestamp that Kaspa understands, which is a format like this. So if you would like to get, for example, transactions, let's grab this transaction, for example. If you would like to, from this transaction onward, for example, then you would have to convert this data to the timestamp that Kaspa understands. So let's grab this. Remember, remember that we want let's pick something that I remember. Let's start from this one. So I want after every transactions forward. So okay, I'm gonna grab this one. I'm gonna convert this to timestamp. Day will be 5. Month is 3. The year is 25. The hour is 14. The minute is 1, and the second is 26. So we get this timestamp, right? Now we're gonna go back to the API. We're gonna use this command. So give transactions for address page. For address, for which address? Well, which one it was? It was this address, remember, 14. This is for this address. Limit, well, we're not gonna say timestamp, and this is where it comes, where our timestamp comes in, and we want after this timestamp. Let's see, A15 is here, but the first one we get, remember that after this timestamp, which means 26p, then CD3, then N94, and then the last one is A15. And the same is for if you would like to before, just that I'm not gonna execute it. Oh, we're gonna execute it. We're gonna execute it before. We're gonna before this timestamp. So that was which one it was? Where it was 13. So now we're gonna go back because we get a lot more information. Where it was before timestamp. And here I'm gonna show you some problem. We probably get information we want. However, because this timestamp doesn't include milliseconds, we are not exactly getting the result. So let's do something different. Let's take this transaction. Let's view it in the Kaspa Explorer, which gives us this, and we're gonna use this one. See this? We got different timestamp because this timestamp includes milliseconds, and this information here on both those sides doesn't include those milliseconds. But if we actually perform this command again, now, okay. ID. No, this is probably the last one. Let's this. Maybe this one. Oh, I've been looking at different DF083. Yeah, we were looking at different and okay. So this is the information. This is the next one, this CDB, and the last one here will be the first one here. Okay, so let's move on. Next one is transaction count. This operation actually is kind of wonky because I think I'm gonna show you why it looks strange to get count for address. an address, and we're gonna transaction count. Let's look on the top 100. I'm gonna show you something. This is this address, the first address on a site. We're gonna 10,000, right? But if you actually go to this address here, you're gonna see this number. Now, if you actually open this address in the Kaspa Explorer, on the other hand, you're gonna get this number. So yeah, it doesn't show how much really transactions there is, because probably some of them are coming directly from nodes. Some of them, I know, maybe coming from database. One is doing that, one it's not. I have no idea. But so if you are getting something like this, which means limit exceeded, then there is more than 10,000 transactions on address, just like it's displayed here. It will not tell you the exact number, just like it's saying on a Kaspa for you site. So you have to be aware of this. Okay, so let's move on to the next one. Get name for address. Name for address is this this thing here. You're gonna see this one here or here. There is no name here. There is name here, and so on. So get name for address, and let's this one. There's a mixed wallet. Let's use this one. Gate.io wallet, but if you're gonna grab this one, you can get this status API request failed with status code not found, because there is no name here. Okay, let's move on. This is the get balances from addresses. This one has a list of the addresses. This is similar to this one, but you can pass here multiple addresses. So get addresses, and let's once again, that's this one. Let's get this one. Let's get this one. And I think that's all for this section 2.